So now that you guys have had a quick little introduction to ratios, we're going to talk about equivalent ratios. So equivalent ratios, they mean the same thing. They equal actually the same, and just like equivalent fractions. So some equivalent fractions here are 1/2, 2/4, 3/6. Okay, we can see that this number goes up by 1, and this number is going up by 2 each time. So we can rewrite that as equivalent ratios. Okay, so 1 to 2, 2 to 4, 3 to 6. Okay, so we can relate equivalent fractions and equivalent ratios. Another example of some equivalent ratios here would be 3 to 1, or 6 to 2, 9 to 3, 12 to 4. So you can see that this number, we have to multiply this number by 3 to get to this number. We have to multiply 2 times 3 to get to 6. You might also see a pattern here, 3, 6, 9, 12. We're counting by 3s. And here we're just going up by 1 each time. So lots of patterns that you can see in ratios as well. So say that I am making banana bread, and I need 2 bananas for 1 cup of flour. So I can write that as a ratio. That's what I would need for 1 loaf. So this is an actual recipe, but so 2 bananas to 1 flour. So now say I want to double this. I want to make about 2 loaves. Well, then I'm going to double this. This. So if I have 4 bananas, I'm going to need 2 cups of flour. If I've got 6 bananas, I'm going to need 3 cups of flour. So here, I'm multiplying this number by 2 to get to this number. And you can also see a pattern here, 2, 4, 6, and then 1, 2, 3. This is going up by 1s, this is going up by 2s each time. So these are also some equivalent ratios. One more set of equivalent ratios here would be 2 to 7, 4 to 14, 6 to 21. So here now I'm going up by 2s each time, and here I'm going up by 7s each time. Or I'm going 7 times 1, 7 times 2, 7 times 3. So these are all equivalent. They are actually the same thing. So with ratios, we can also find the missing numbers. So for example, if I have 1 to 4, and that equals something to 12. Well, how did I get from 4 to 12? Oh, I had to multiply 4 times 3 to get to 12, so I'm going to multiply this by 3. So 1 times 3 is 3. Okay. Another example here, then I've got 3 to 5. We're going to find what that's equivalent to. So it's something to 20. So to get from 5 to 20, I had to multiply by 4. So that means I'm going to have to multiply this by 4 as well. So 3 times 4 is 12, so I can fill that in there. Okay? So we can find the missing number using some equivalent ratios. Now let's do a little word problem. So I have 2 red balloons for every 3 pink balloons in a little balloon bouquet. So if I had 8 red balloons, I want to know how many pink balloons I would have. So I can write ratios for this. So for every 2 red balloons, I have 3 pink. And I'm just going to label this up here. Red, pink. So if I have 4 red balloons, I'm going to have 6 pink balloons. If I have 6 red balloons, I'm going to have 9 pink balloons. And if I have 8 red balloons, I'm going to have 12 pink balloons. Okay, notice here that this is going up by 2s, this here is going up by 3s. So if I double this, I have to double this. But then what happens here? Well, I'm not doubling all the time anymore. For every 2 balloons, I have 3 pink balloons. So if I was drawing balloons, here's my red, and here's my pink. Okay, just making sure you guys can see that. 3. Then if I have 4, well, I'm going to double this. Okay, and then if I have 6, well, I'm only drawing 3 more pink balloons for every 2 red balloons that I have. So it's not always going to be double. It just happened to work out like that in the first one, but then later on, that's not always the pattern. Okay, so you just have to be mindful of that. So you can draw pictures for it, just like I did here. 2 red balloons, 3 pink balloons, 2 more red balloons, 3 more pink balloons, 2 more red balloons, 3 more pink balloons, and then finally 2 more red balloons, 3 more pink balloons, and I can count up. Now I've essentially drawn a multiplication array, so now I can count up. Okay, I've got 8 red balloons, that means I have 12 pink balloons.